In this video, we're going to talk about the side-angle-side criterion for similar triangles. Remember, we say that two triangles are similar if their corresponding angles are congruent and the lengths of their corresponding sides have the same ratio. We have the angle-angle criterion that allows us to quickly check whether two triangles are similar, and now we will introduce another criterion, the side-angle-side criterion. Here's how the side-angle-side criterion goes. If two pairs of corresponding sides share the same length ratio, and their included angles are congruent, then the two triangles are similar. Now, there is one caution in applying the side-angle-side criterion, and that caution is as follows. If two triangles do not satisfy the side-angle-side criterion, then we cannot tell whether they are similar. We know that if two triangles do satisfy the side-angle-side criterion, then they are similar, and therefore it's really tempting to say that if two triangles don't satisfy the side-angle-side criterion, then they're not similar. But this isn't always true. Sometimes we just don't know enough about the triangles to tell whether they're similar. So if two triangles don't satisfy this criterion, they still may or may not be similar. We just don't have enough information to tell. Alright, so let's move on to some examples. We want to tell whether the given triangles are similar. Starting with this example, we've got two triangles. The first one, the small one, has sides 3 and 7 with an included angle of 50 degrees. The larger one has sides 12 and 28 with an included angle of 50 degrees also. So good, we see 50 degrees matches 50 degrees. The included angles are congruent, so that's good. That means that if the sides have the same ratio, then side angle side applies. So let's go ahead and check the ratios of the sides. First of all, let's check the small sides. So 12 and 3. These are the corresponding 12. These are the corresponding small sides, and we can check that ratio. That ratio 12 to 3, that simplifies to just 4. 12 divided by 3 is 4. And let's also check the ratio of the other sides, 7 and 28. These are another pair of corresponding sides, and 28 to 7, that ratio is equivalent also to 4. So because these two pairs of corresponding sides share the same length ratio, which is 4, and their included angles are congruent at 50 degrees, we can conclude by the side-angle-side criterion that, yes, these two triangles are similar. Okay, onward to the next example. The small triangle here has sides 4 and 5 with an included angle of 30 degrees. The large triangle has sides 8 and 9 with an included angle of 30 degrees. And again, we see that the included angles, both 30 degrees, so that satisfies the angle portion. And now let's check the length ratio portion of the corresponding sides. First of all, let's look at the smaller sides in each of the triangles. Let's look at 4 and 8. These are corresponding sides, and let's see what the ratio of these sides is. 8 to 4, that simplifies to just 2. 8 divided by 4 is 2. Now let's check if that matches up with the other pair of corresponding sides, 5 and 9. The ratio 9 to 5, does that simplify to 2? No, it doesn't. It doesn't. That doesn't simplify at all. So that's not equal to 2. So therefore, these two triangles do not satisfy the side-angle-side criterion. But that just means that we can't tell whether or not they're similar. So our conclusion is really just, we can't tell. Alright, last pair of triangles. The small triangle here has sides 5 and 3 with an included angle of 40 degrees. The big triangle here has sides 10 and 6 with an included angle of 35 degrees. And right away we see that these included angles, 40 degrees and 35 degrees, they are not congruent. They don't have the same measure. 35 degrees not equal to 40 degrees. And therefore the angle part of side angle side is not satisfied. So it doesn't even matter if these corresponding sides share the same length ratio. Since the angle part isn't satisfied, then side angle side criterion is not satisfied, and therefore we can't tell whether the triangles are similar. Alright, so here's a problem. I want to solve for x in this diagram below. This diagram really just consists of two triangles, and there's also some parallel lines here. This top line segment here is parallel to this bottom line segment there. Alright, so whenever parallel lines are cut by a transversal, we know that some congruent angles appear. Namely, there's alternate interior angles that appear, and we have those angles right here. That's this angle and that angle. So these two angles are congruent. So this leads us to start thinking maybe if we can show these two triangles are similar in some way, then we can set up a proportion to solve for x. But first, let's see if these two triangles are even similar. We've got a pair of congruent angles, so if we want to use side angle side, we should start thinking about comparing the ratios of lengths of supposedly corresponding sides. So first of all, what is the corresponding side for the side have length 2 here? Well, 2 is the smallest length in this triangle of lengths 2, 3, and 4, so we should be comparing this side 2 to the smallest length in the other triangle, which appears to be this 4 side here. So let's compare 2 to 4. The ratio of 2 to 4, or rather of 4 to 2, 4 divided by 2 is just 2. Okay, so now let's check the ratio of the other pair of corresponding sides. So looking at this angle, we've already got this side, we got the side 2, so now let's start with the side 4 on the other side of that angle. So that side 4, what is the other corresponding side? Well, think 4 is the largest side of the small triangle, so the other corresponding side should be the largest side of this big triangle. And the largest side here is given by 8. So let's check that ratio. Ratio of 8 to 4 is equal to 2. So since we have two pairs of corresponding sides with the same length ratio, and also their included angles are congruent, we can conclude that the triangles are similar by side angle side. And we know that in similar triangles, all of the pairs of corresponding sides have the same length ratio. So that other pair of corresponding sides, 3 and x plus 5, that needs to have a length ratio of 2. So we can use that to set up an equation, length of the bigger triangle, x plus 5, divided by length of the smaller triangle, 3, that length ratio has to be equal to 2. So if x plus 5 over 3 is equal to 2, we can just multiply both sides by 3 to get rid of that denominator. We get x plus 5 is equal to 3 times 2, which is 6. And so if x plus 5 is equal to 6, we just subtract 5 from both sides and get x is equal to 6 minus 5, which is just 1. So there we go, there's the solution. X is equal to 1. So now we have several criteria, including the side angle side criterion, for checking whether two triangles are similar. And knowing that two triangles are similar is going to be very useful in the future because it allows us to use side length ratios and angle congruences to set up equations.